Thank you for being patient. It's about to change gears here. Tonight's going to be exciting because we're going to work with these for the first time. Do you remember these from the first video? These are the thermoelectric Peltier coolers. I moved everything over to this nice new bench. I wanted to make sure that everything survived the move. So when we press this button, yep, we're maxing out at 2.3 amps. We can still read it on the screen. So to make this work, I'm going to solder this little switch onto the thermoelectric cooler so I can turn it on and off at will separately from the rest of the system. Now I'm going back to the original circuit. I'm going to disconnect the power resistors from the circuit. And in place, I'm going to put the thermoelectric Peltier junction with the series switch on it. And we're going to turn on the supply when the value on that screen is very low. Turning it on. Yes, okay, we see some current going in. This is going to be the really, really interesting part here. Thank you for being patient. It's about to change gears here. Instead of just being about a whole bunch of numbers on a screen, we are going to create, ladies and gentlemen, not only heat, but cold. And this is exciting to me because I have never actually worked with these things. Let me introduce a really cool tool. This is just a laser pointer and a thermometer combined into like a gun. Kind of shoots, you know, maybe a couple feet in front of it, and it tells you how warm or cool something is. This is November and I got the heat on. So when I aim this like ambiently at the table, it's about 72 degrees. When I aim it at that wall, it's about 72. I bet if I aim it at the output of that computer, yeah, see that's around 92. Our goal here is to get this thing here, the Peltier junction, warming and cooling. And as I understand it, forward current will warm it and reverse current will cool it. Yeah, I don't know what's going to happen here, but I'm gonna switch it on. And let's just see if it gets warmer or cool or gets a motor fault or what. All right, so there we go. We're shooting almost a little over an amp through it. And if I put this on here, oh my God, it says 60. Look at that. Okay, now it's 65. Now it's back to ambient at 72 forward current and it's going up 70. Look at that, it's actually heating up. That's 80. Whoa, that's 100 degrees and still warming up. Okay. So now let's see if it cools off. It's at 100. Yeah, can you see? That is actually cooling off. Let's see how cold it gets though. Yeah, okay, so it only got down to 76, 77. So what we could see is that the heat is much more efficient. I want to touch that and just feel it get from warmer to cold. Okay. Yeah, okay, ooh, the left is definitely hot right now. And that's another interesting thing about this, is when one side gets hot, it's the other side that gets cold. And oh yeah, now the right side is getting hot. It's not too hot to touch. As we saw, it's 100, so it's like a warm bath. But my friends, this is a very good little result here. There it's shifting. What I want to do now is change the program a little bit so it lets it get really cold. Now the only thing is that means it's going to get really hot on the other side. So eventually we're going to need like some kind of heat sinks and fans with these things. A different kind of load on this thing, actually. We're not just going to be using bare thermoelectric coolers in the secret project.